Welcome to my presentation. In this presentation, we shall see how to perform vector operations in two dimensions using the vector properties. So in here, let us say, in this example, if V is a vector and it has 2i plus 5j as its components, and if W is a vector where it has 6i minus 3j as its components, we want to find vector v dot vector w, right? And then to do that, we're going to follow these different steps. The steps are vector v dot vector w. We're going to write this one out as follows: 2i plus 5j dot 6i minus 3j. When we do the dot product, we want to make sure that we understand this. I dot I is equal to 1, and then j dot j is also equal to 1. Similarly, I dot j is equal to 0 and j dot I is equal to 0. So we'll keep that in mind when we are simplifying these. So in step number 3, we're going to expand this and see how we can simplify this. 2i times 6i plus 2i times negative 3j plus 5j times 6i plus 5j times negative 3j. As we can see, I dot j, this is going to go to 0, j dot I, this is going to go to 0. So therefore what we have here is 2 times 6 is 12, I dot I is 1, so we don't need to write that, plus j dot j is 1, so 5 times 3 is 15 with a negative sign, so therefore negative 15. Therefore when we simplify this, 12 minus 15 is negative 3. So therefore the dot product of two vectors is always going to be a scalar quantity. It is not going to be another vector. It is going to be a scalar quantity or a constant number like this. So this is how we can use the dot product property to solve operations of vectors. In my next presentation, we shall look at some more examples related to vector operations using the properties of vectors.